right? We're not adding, we're solving the equation, correct?
Yeah.
Okay, perfect. So we have log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1, correct? Good. So remember, log
Yes.
is not a friendly function. I have to write x plus 6 greater than 0 and x plus 5 greater than 0. If you don't want to find the domain, it's fine, but you have to go back. You have to commit yourself to checking. Otherwise, you may not get the full credit. So now I solve this, and I find the common domain. You don't have to rush. You can just graph it. Common domains means common territory, common area. So from -6 to infinity, and from -5 to infinity. And the common domain is when we have both colors, red and green at the same time. Do they overlap?
Yes, -5 to infinity.
Good. So then you don't have to go back and check, but you have to come back here and make sure that the number we get is greater than -5. If we don't get a number greater than -5, then the equation has no solutions. Okay, so now we condense. Only now, you cannot condense and then state a domain. You have to state a domain on the raw equation and then condense. So if you remember that when we add logs, this really comes from log applied to the product. And now this is equivalent to 2 raised to the first power equals this. So 2, and I'll try to cut back on writing a little bit if possible. I distribute, so this is x squared. 5x and 6x is positive 11x and plus 30. At this point, I know that I'm dealing with a quadratic equation, and I have to set it equal to 0. I hope that it's easily factorable. And it is. So I have 4 and 7. And then I get 2 solutions. But if I forget to go back and check, I will definitely not get full credit. Because solutions are accepted only as long as they are greater than -5. And the only solution that is greater than -5 is this one, -4. No, this one is not. So, any questions on this so far? Is this okay?
Yep.
Good. Okay.
Can we do number 20, which is solving the system?
Yes, of course. The Gauss-Jordan? Is that the Gauss-Jordan?
No.
Oh, okay. So you said...
that one's next.
the 18? The 8x minus 4y?
Either or. They're both systems.
So which one did
I was
you...
looking at 20 as well.
Oh, 20. Yeah, no. Let's go into... No, I'm sorry. I thought...
Yeah, because I think 18 circled and it says no, but either or.
That's fine. Let's do 20. No. So, because that one is too easy. And I don't want to put too many problems that are identical. plus y plus 6 equals 34. Perfect. Well, we know three methods. Gauss-Jordan, no, of course not. Elimination and substitution. I can eliminate. This variable is not the same with this variable, and this variable is not the same with this variable. So elimination is out. Gauss-Jordan, of course, is out. So my only chance is substitution. It doesn't matter which one you want to substitute for because both of them have 1 as coefficients. So we substitute for x. I mean, we solve for x or we solve for y. It does not matter. Which one would you like to solve for?
X.
Perfect. Okay. So then I have x equals negative y minus 11. I will replace x in the second equation by negative y minus 11. So negative y minus 11 minus 3, everything squared, plus, I'm going to expand this. When we square binomial, how many terms do we get?
Three.
Very good, thank you very much. Y squared plus 2 times the first times the second, plus the second term squared. Of course, I'm going to subtract 34 and get 0. Now I have to be careful with this. What do I have here is basically negative y minus 14. When I square a binomial with both terms negative, is like squaring this. Because here, all terms will be negative, but when I square them, all terms will be positive. So why bother? If only one of them is negative, I cannot do this. If only this one is negative and not this one, I cannot do that. But as long as both of them are negative, it's like factoring out negative 1 and squaring it, and you get that. So therefore, we have y squared plus 2 times the first times the second, plus 14 squared. I got 196, yes. And then plus y squared plus 12y. And I had 36 minus 34, so positive 2 equals 0. I shouldn't put it away because I need to check later. Okay, so I combine like terms. 2y squared. I think I
20.
Yeah,
28y, right?
Yep, I swallowed the y. Yeah, and I'm not hungry though. 28 plus 12 is 40. And 196 plus 2 is 198. And I'm definitely hoping that at least I can divide by 2 and get rid of that. So I have y squared plus 20y plus 99 equals 0. And if I don't see 9 and 11, I can use the quadratic formula. The product is 99, the sum is 20. So there are two options, y equals negative 9 and y equals negative 11. But remember, that's good, but that's not good enough. Oh. Yeah, of course, because I put it underneath here. Okay, so I have x equals negative y. Negative 9 is 9 minus 11. Oops, x is negative 2. And negative 11 minus 11, negative 11 minus, with minus in front is positive, so then this is y equals 0. Of course, if I didn't delete it, I wrote y twice. Well, I mean x, of course. So x. So the system appears to have the following solutions. Negative 2, negative 9. And 0, negative 11. I can copy it or go back to the original system to check. And let me copy it here. X minus 3 and then plus y plus 6 equals 34. Okay. So I'm checking -2, -9. This is obvious. The system had -11 there, sorry. So -2 minus 9 is indeed correct. -2 minus 3 is -5 squared, which is 25. -9 plus 6 is -3 squared, which is 9. 25 plus 9 is 34, yes. So I will say yes to this one. Now I have to check 0, -11. So 0, -11, 0, -11. 0 minus 11 is -11, yes. 0 minus 3 is -3 squared, which is 9. -11 plus 6 is -5. -5 squared is 25. And the answer is indeed 34. And I will say yes to both.
Now can we do 23,
Yes.
which is a Gauss-Jordan
Yes,
system?
of course. 23, I see it. So we have x plus y plus z equals 0. Watch me copying because you know minus y minus z equals -4 and x minus y plus z equals 2. Okay, I like the system because it's presented correctly as I needed it to be. So I can immediately create the augmented matrix 1, 1, 1. 1, -1, -1, 1, -1, 1, and 0, -4, 2. This is already accomplished. Now I'm here. I need to get the zeros corresponding to the zeros in column 1. So in the first step, we have to use row 1 and multiply by something and add it to row 2. And then multiply by something, maybe the same or something else, and add it to row 3. So what should we multiply by?
-1.
Yes, by -1 in both cases. Which row do I copy?
The first row.
Yes, so 1, 1, 1, 0. 1 times -1 plus 1. 1 times -1, -1, minus 1, -2. 1 times -1, -1, minus 1, -2. 0 times -1, 0, minus 4, minus 4. So far, so good?
Yes.
1 times -1 minus 1, of course, it has to be 0. 1 times -1 is -1 minus 1 is -2. And 1 times -1 is -1 plus 1 will be 0. And 0 times -1 still 0 and 2. Okay, so now our next step must be here. This is already done. It cannot change for the duration of the problem anymore. It's done, carved in stone. Obviously, we have to do something to get a 1 here because the 1 will help us eliminate these two. There are variations to the method. We can get sophisticated. We can multiply first by -1 and add it here. We don't need to get any, we have to stick, I think, to the rules. So I need a 1 here. How do I get a 1 in that spot?
Divided by -2.
Very good. So I copy 1, 1, 1, 0. I copy 0, 1, 1, 2. -2 divided by -2 is 1. -2 divided by -2 is 1. -4 divided by -2 is 2. I copy 0, -2, 0, and 2. And now my focus is here. And now I have to use row 2 to add it to row 1 and row 2 to add it to row 3. This will help us eliminate this and eliminate that.
-1.
Very good. The first one with -1. And for 3?
2.
Excellent. In the next step, which row do I copy? Because it cannot change. It's the one I'm using, so I cannot at this stage. It may change later, but not now. Yeah. One times -1 plus 1. 1 times -1 plus 1. Nice. 2 times -1 plus 0. 2 times 1 minus 2. 2 times 1 plus 0. 2 times 2 is 4. 4 plus 2 is 6. All this is done. Now our focus is here. Row 3, divided both sides by?
2.
By 2. So then 1, 0, 0, -2, 0, 1, 1, 2, 0, 0, 2 divided by 2 is 1, 6 divided by 2 is 3. Good. This is the only and final concern. Everything else is done. I just need a 0 here. So obviously I have to use row 3 and add it to row 2. What do I multiply it by and add it to row 2? So I can eliminate the 1.
-1.
That's it. -1. So of course 0, 0, 1, and 3. And 1, 0, 1, 0 cannot change, and 0 and -2 cannot change. 1 times -1 plus 1 is 0. 3 times -1 plus 2, -1. And the triple that I don't know whether it works or not is
-2, -1, 3.
-2, -1, 3, -2, -1, 3, -2, -1, 3. Perfect. Okay, so let's check. -2 minus 1 is -3 plus 3. -2 but plus 1 is -1. -1 minus 3, it is -4. -2 but plus 1 is -1 plus 3 is 2. A sigh of relief? Yes, I checked.